Good evening, everyone. So we'll wait a couple more minutes till we have some more people joining in. Meanwhile, let's look at major issues going in the ED. Meanwhile, do you guys have any questions related to your assignments? Because I'm not seeing. Yeah, so this is good. Regarding assignment, going to the assignment specification, we've been instructed to work on the CRUD feature of the data for the roles identified in the assignment. Are we allowed to assume that what would be the specific CRUD features be? As we proceed forward, we'll be learning about Springer. However, if we had to start working on the assignment, having prior knowledge about the framework, is it fine to look? The expectations for the week 4 submission, which is this week's submissions, are pretty simple. So after we complete this week, you should be able to do end-to-end web as well as transactions using databases. All right. So my expectations is that, and teaching team expectations is that you read the case study and understand what is required and check with your teaching team by posting questions specific to things like what CRUD features would be you'll be doing, what roles you have identified. So you need to list all those into your design document. We don't say that this will be your final design document. What we are saying is this is tentative, and as we go to further weeks, you'd improve it. And we have Gwen here. Hi, Gwen. Have a good evening.
Hi, Neil. Yeah.
So, yeah, the students have some questions on the assignments and all, maybe.
Okay, so I'll try to answer the questions at the same time. The report should be due on, yeah, so the report should be due on week 5, yes.
It's just beginning of week 5, isn't it?
Yeah, we just said week 5, there's no specifications about, yeah, all right.
So they can read the use case and get back to us with questions related to the use case at the moment, which is basically to
Okay.
reflect their understanding on the use cases and things like that.
Yeah.
Anything you want to add, Gwen, on the assignment side?
No, actually, basically, so you should start working on that. Download the report, the template, and also the specification should start working on that. And so we hope that you can submit your first deliverable, which is, the report, design report in week 5, which is next week.
So,
then
sorry.
We can, okay, then we can give you the feedback, right, as soon as possible. Yes. Okay.
Is there any submission link that we need to submit?
You just submit to the the eFolio system. You can create a eFolio folder like assignment, right? Just subfolder in your eFolio shared folder. Underneath there, you can create a assignment folder. Then put your document there.
Then what is the exact due date? Like, is there any late punishment penalties?
Okay, there's no penalty. This is a submit for feedback, all right? So we don't want you to submit, all of a sudden at the last minute in week 12, right? So we want you to submit, gradually submit something so that we can give you feedback so you can improve your work. This is the approach so we adopt to, to do this assignment.
Okay.
Yes.
Okay.
Yeah.
Okay, and JDBC connection pool, click and add properties, 500 error happened. So 500 is server error. That means server did not fulfill the request. Do we have, okay. Use glassface 0 instead of glassface 5.0.1. So use a stable version. Maybe that would resolve this. Okay, we have few people already, and I will not wait further. We'll go to this week. All right, there's a lot of people having issues in the tutorial. Major issues is name already bind, like name already bound exception. This is something which is covered in your week 3 demo video, you know, the lab video been uploaded. You can go and check. Uh, so if you watch that video, most probably you will clear out half of your issues here. The simple thing is from week 1, you do have a loan managed bean in the loan bean already in the EJB container. So that's why EJB container is not able to initialize. That's why you're facing this issue. So just remove everything, undeploy and redeploy. You should be able to. Good job, Cesar, for giving useful feedback. All right. Another thing, as I promised you last week to share you some demo material for Ajax, jQuery, and things like that. So if you go to week 2 of your Moodle, we have uploaded a sample, very simple example of using Ajax and jQuery for date picker, and a simple explanation of JSF get and post request and the difference between them. This is the project file, and if you go to the lab demo part, you have one more video on the week 2 Ajax jQuery JSF manage pins with some extra stuff. You can have a look at that. There are some use cases, explanations, and related inputs and feedbacks, which will be useful if you can make use of it. So I highly recommend you guys to make use of the resources, especially the demo resources which are provided to you. Let's come back to week 4. So we'll be working with Java persistence this week. So these are the lecture chapters from the textbook and some extra materials, reference materials. Okay, so there is an ISA2 feedback here. So this feedback is for everyone. You can make use of it to provide any feedback that you have regarding teaching team or your course materials, or anything that you would like to see some improvements, or anything that you want to, you know, regarding unit design and anything. You can provide your inputs here. All right, there are 2 useful materials. One is lab video that tells you about the configurations of the databases. And second one is to debug and how to implement the solution. So to give you a context of what we will be teaching this week is purely Java persistence. So I'm going to pull up this thing here. This is something you would have seen last week. And I'm gonna pull up this one here. So these are kind of same diagrams with little or more improvements. So at the moment, you guys know how to build a web part. You guys also know how to build a EJB project, but you haven't touched this part, the persistence part, correct? So in EJB, we use EJB as the data access layer to do all the business logic. So EJB will be accessing the database server. So for your project point of view, you need to install database, which is download the Derby libraries and the jar files, configure configure your persistence.xml, the persistence unit, and the glassfish resources to point to the JDBC JNDI name and the JDBC resource pool that you're going to create database in the database. Basically, we'll be introducing in your EJB project one more configuration file, and that configuration file is persistence.xml. This configuration file will have some contents. Okay, these contents, I'll pull it up to show it to you. Persistence.xml, I'll go to EJB project, meta-nf, persistence.xml. So this is a sample persistence XML file which have a persistence unit name and what is the JPA provider, persistence provider, and some resources like JNDI name for the resource pool. And the classes this persistence unit is going to manage. And these are the classes. And these classes should have the required annotation of @entity. We'll talk about a bit more about what is @entity in the coming slides. So before that, you create a JNDI name to the pointed to the JDBC resource pool, and those informations are actually captured in the Glassfish server. So if you see, Glassfish server will know those, will need to know those information in order to connect to the database. So EJB container is inside the Glassfish server, and EJB will share those details. EJB container will share those details, and it will use that interface to connect to the database. So you'll find the same JNDI name with the required JDBC resource connected to the JDBC resource pool, and the resources. So you have a resource and a connection pool. You first create a connection pool with a specific URL and with details like server name, port, database name, user, password, likewise. So there are a few things which is present in the Glassfish resource.xml, which is used by the persistence to map the classes, and the Glassfish use those information in order to connect to the database and get some dependencies back to the persistence context wherever this persistence unit is used. So this is a little bit of behind the scene stories, and I'll get you this. So what happens? There's a request that comes to the faces controller. There's the parent controller. Once a request comes to the parent controller, there are some JSF pages which is requested for. And whatever managed beans are used in the expression language of that JSF page view, yes, you can. Sorry, there is a question from the chat. If we can use dot properties file. Yes, you can. We will eventually use that in your Spring part. So hold on to your curiosity. So I was explaining, when a request comes to the facelet controller for a JSF view, the view will have some kind of manage pane used in the expression language, and based on the manage beans used in the expression language, those manage beans will be instantiated. Those are like the models. The JSF pages are the views. This all happen in the web container. Now inside manage beans, you have annotations like @EJB, which creates a dependency to call at the rate when you use @EJB, basically it injects an instance of EJB functions into the manage beans, and there is how you can do business logic in the manage beans. Basically, you don't do the business logic in the manage beans. You basically call the functions of the EJB using the dependency injected using @EJB. Okay. So if you have simple functions to do in your EJB, basically you don't need to access a database. You can work it out. If you need to access some data from database, so what EJB will do, I did mention, showed you last week. Perhaps this part of the thing. What EJB will do, so you injected an EJB in your MB, and an instance of the EJB was created here, right? And inside that EJB, you use a persistence context and get access to entity manager. So if you have just one persistence context in your persistence.xml file, in that case, you don't need to provide a name in persistence context. All right, and you don't need to provide a name in the persistence context. However, like if you see, we can have multiple persistence unit here, each connecting to different stuff. So if you have that case, in that case, you can actually pass which persistence context you want to use. So when you pass the persistence context here, this specific entity manager is injected. So you have lot of examples of dependency injections here using annotation. This is something important I'm saying. You have lot of dependency injections, like using @EJB, you are injecting an EJB. Using @persistence context, you're injecting an entity manager. So once you get hold of an entity manager, you should be able to do database operations. Database operations include your create, read, update, delete, all the CRUD operations. So here, the EJB, once it gets hold to the entity manager, for the specific persistence context, whatever classes are mentioned, it can manage them. Okay, and these classes are special classes. These are not ordinary classes. These classes should have an annotation @entity. So these are some compulsory annotations @entity. What basically this annotation does is it maps the relation, the entity, the Java class into a database table. Okay, and then just like every table has a definition, table definition, which you create through DDL commands like create table, table name, primary key, ID, type, varchar, or integer, something like that. Similarly, your class is a definition of a real world entity, and annotating the class, a POJO class with @entity, makes this class manageable. What do I mean by manageable? Is manageable by your persistence, manageable by your entity manager. Now, after I put @entity, class, this class, which is part of this persistence unit, is now manageable by the entity manager. Now, using this entity manager, I can do all my CRUD operations. My CRUD operations like persist, like creating is persisting, updating is merging, deleting is removing, and find is selecting. So these are the simple CRUD operations what you can do. I hope you have got this idea here. So once you get hold of the entity manager, you use the JPA, the relation ORM mapping, for the classes to get hold of respective objects, whatever you want. You can pass a JPQL query, Java Processing Query Language, and get hold of the database table and return results to the EJB. Now EJB can process them, and then whatever selected results, what it needs to filter and send, it can send it back to the manage bin. Inside manage bin, this will be assigned to a property, like a list of property, an array list, something like that. And then the view, it will be set on the view views attributes, and response will be sent back as an HTML with the details of the data that has been fetched from database. All right, this is what the holistic picture is. Now we'll go back to our slides. Okay, slides. So one request, guys. What happens is that when I start explaining things, I do get a lot of people joining in between, who are going into a waiting room. I do start the lecture at least 10 minutes after 6, post 6 p.m. So you can use that buffer to join in. So if you keep joining in between, it creates a kind of distraction to me while I'm explaining something, or I'm middle of something. So I request everyone to make sure they join at least by 6:10. Thank you. Okay, so we pull up today's slides. So there are like 97 slides. I will try to cover the concepts and then slide through quickly. However, I will request you guys to always refer to the textbook chapters for better understanding of these topics. Okay, I always prefer you guys to refer to this textbook. By this time, you should be, this textbook is a very small textbook, you know, it's like 600-page textbook, and half of it is codes and everything. So you can just quickly skim through it and get a lot of valuable information out of it. Okay, for this week is about Java persistence. we know what we did last week. We did some session beans, implementing business logic, some finer aspects of EJB's implementations. This week we'll be using JPA to communicate with database standalone applications, and some advanced ORM. ORM stands from object relation mapping, and criteria APIs and container managed entity manager. Okay. So when I used when I use this, I'm actually using container manage entity manager. I'm not manually managing my entities. So EM is a dependency injection of managing through container manage entity manager. So this is an example of dependency injection of container managed entity manager. Okay. Persistence. What is persistence? Persistence in relation to an application development relates to data being stored permanently, so it can be reused in the future. And example is storing data into your file system or into a database. So there are two approaches for serialization. One is JDBC connectivity, and another is object relation mapping. What happens in JDBC connectivity is you provide the drivers. Drivers are like, so you have one system, I have one system. What can talk to these two systems? Basically, what can talk to the two different kernels is a driver. So JDBC is a Java driver that can talk from Java, and it used to pass native queries, be it Oracle or MySQL queries. And object relation mapping is a little different part of it, where you don't you have multiple ways of querying. However, you have Java mapped to relations. So it's object relation mapping. The class, the object of a class being mapped to a relation in a database. So we know what is relation. It's like converting an object into a sequence of bits and storing it a file, maybe it in a database or anything. JDBC connectivity we just discussed, uses SQL to retrieve and manage data. It doesn't support objects to relation paradigm, and to work with that, you should know both both the languages. That is, you need to know Java as well as you need to know um, Oracle or whatever database you're working with. The mapping process is very time consuming, and it's quite error prone. Sometimes you will have one conventions in Java and another conventions in Oracle or the database that you're using. Cool. The ORM. So this is the technology that you will be using. So ORM is a technology that converts data stored as an objects into relational database structures, and vice versa. So you can create your entity classes from database, or you can have your entity classes and then create your database. So it works both ways, all right? What advantage it has, it allows developer to focus on the object model instead of mapping of object-oriented and relational paradigms. We'll see how it happens in the future. It supports advanced object-oriented concepts like inheritance and things like that, and it's not limited to Java. There are many products available, Hibernate, Active JDBC, or MyBetis and things like that. Okay. So ORM is the technology. The JPA is the technical specification. Okay. And as a part of EJB3, JPA is the standard technical specification that provides details for the standard interface APIs to access, persist, and manage data. Okay. And there are different implementers for this JPA. You have Hibernate, you have Eclipse Link, you have many other in the market. Probably if you look into this persistence XML, you'll see you're using Eclipse Link for detail generation. Yep. So this is your JPA provider. Okay. Eclipse persistence is your JPA provider. So you have databases. What is the database? Okay. I hope you guys have done your foundations. You know what is a database is. So database is basically a collection of data. And if I say what is relational database, so this is the favorite part where datas are organized in particular structure in which each tables or relations, they have relation among each other. Each tables have relations. So that is relational database, which is very popular. And then we have a few more database design as well, like hierarchical, network, and object oriented. There are a few examples of it. Um, like in social media, they use hierarchical for network, likewise. So relation, when we talk about, when we use this term as relation, it's commonly known as table in your database. Okay. So what does table contain? It contains collections of data related to a particular domain object, and it is organized in rows and columns. Each row is an object and each column is an attribute, corresponding attribute. So if you see attribute, it corresponds to a column in a table. Okay. A record or a tuple corresponds to a row in a table, and an object of a class. How do you identify unique tuples? So tuples means a record in a database. Yes, you're correct. The primary key. So tuples are the rows. So primary key is used to identify each row. So the annotations in your class for that specific column, which is marked as an primary key, will be, yes, you got it right. It's @ID. So if I show you this example here with property, uh, so this is having @entity. So this is mapped, and this is @ID. So you can put this annotation here, or you can use it before getters and setters. Okay. Uh, those are just different ways of doing it. It's not big
Do we
thing.
have to put it like in either place, or we can put it on both?
So if you put it here, there are two ways in which you can access by property, access by field. The best way to put is put it on the getters. You'll see most of the annotations on the getters. Yeah, getters is the best place to put it. Okay. So joins. A record among tables can be linked by primary key and foreign keys and can be queried. Cardinality. Cardinality defines or describes the number of records in one table that can be related to another table. How many kinds of cardinality do we have in RDBMS? What are those? Basically, you have three types. If somebody says it's 4, it's basically they mean one to many and many to one. So I'll consider that as the same. So in one way, you have one to one, one to many, and many to many. The relationship can be optional. So this is like a crowfoot notation. Can somebody tell me what is the relation between the subject and the tutorial classes? I'll particularly say it's 1 to 0 or 1 or many. You see this 0 here? It's for that. And what's between tutor and the tutorial classes? From the tutor to tutorial classes? Good. So this 0 signifies it can be 0 or 1 or many. This is 1 or many. Good. So the core components of JPA. So you have ORM technology, the entity manager to manage the entities, and JPQL to read or fetch things from the database. It's a Java persistence query language. And then you have JTA. JTA is the implementation of JPA. And then you have callbacks and listeners. We just discussed about what is an entity. I showed you an example of property thing. Basically, it is a term to describe a domain object that can be persisted in a database. It corresponds to a table. Okay. This is how it looks like. If you have a serializable class that has @entity, that means it can be managed by an entity manager, and it should have at least one annotation that is @ID. So @ID is a kind of compulsory thing. Okay, guys, just give me a small break. I'll just be back in less than a minute. Yeah. So we have an example of the entity classes, and then it says what are the requirements for the entity classes. It should have @entity annotation. It should have public protected default constructor. The class must not be final. It should implement serializable. If its object is passed by value as detached object, all attributes must be private, protected, or package private. They must be accessed only by accessors and business methods. So mapping metadata. So JPA maps objects to a database via metadata. So you can have XML descriptors, you can have annotations. We are using annotations. Okay. The persistent fields and properties. Information about mapping between attributes of classes tables is specified using annotations. Annotations can be applied to instance variable directly, that is persistent fields, or on the accessors, that is persistent properties. So you can use this annotation on the fields or on the accessors, the getters. So if you put it on an instance variable directly, that is persistent fields. If you put it on accessors, those are persistent properties. Persistent fields are used, the JPA runtime access the instance variable directly. If it is persistence properties, then JPA runtime access the instance variable via accessors and mutators. So there is a bit of the best practice. That's why it is to put them in the accessors. The reason is that when you're trying to access that object, it will not directly access the field. It will use the uh, getters to get the value. Okay. So if I have an object of a property, right? Let's say, I'll just say you here. So if I have an object of this, there is a difference between p dot get id. id is equals to, and then there is a difference. id is equals to p dot id. So this this is the field one. This is the property one. I hope you get the difference here. And then if you annotate any specific field as @transient, in that case, it will not be persisted to the database. And then you have configuration by exception. If not explicitly specified, the entity name is mapped to a table name. So I have property. So if I don't specify any name here, in that case, I haven't specified any name. So the table name will be property. Let's say contact person. I have mentioned table name is equals to contact person. That means I will not have the table name as contact person. I'll have contact underscore person as the name of my table. You see the difference, the contrast? And that is done by another annotation called @table. Cool. So these are the few basic custom mapping customization that we came across. ID and generated value. So if you don't want your ID, if you want a sequencer to be used to generate an ID, you can use some examples like this, or for property, use a sequencer, create a sequencer in your database and use it as a strategy. So you have multiple strategies to use. You can use this, or you can use this. Okay. And then temporal is used to map the data types between java.util_date and java.sql_date. Okay. And transient, if you use @transient on any attribute, that specific attribute will not be persisted. The centerpiece of API is entity manager. I've been talking about this from the beginning. Entity manager, entity manager, entity manager. This is getting a dependency to container manager, entity manager, where the container will be responsible for persisting, updating, retrieving, and deleting entities to or from the database. It serves as a bridge between the object-oriented paradigm and the relational world, and is implemented by a persistence provider. Obtaining an entity manager. So you can get the entity manager from entity manager factory, and that is an old way of doing it. We don't do it now, but in textbook there are some references, you can use it. So that is quite complex. The developer has to be really careful about creating the transactions, persisting the data, and then committing the data and things like that. However, if you use resource injection like this, in this is container managed. In that case, you don't have to manually manage it. It will be managed by the container itself, the EJB container itself. Okay. So you can see what is application manager, entity manager. You have the methods. Persist is to create, merge is to update, refresh is to get the updated value from the managed state. Find is to find from the database, and remove is to remove a specific row from the table. Okay. So this is an entity lifecycle. When you use something like new customer, and customer has this annotation at the rate entity, then it exists in the memory. And then when you use persist, persist creates what? It creates a record in the database. So it will go into managed state, and then it will be updated to the database. If you're using application manage, in that case, you have to commit in order to update the database. Otherwise, it will stay in the managed state only. So if it's the managed state and it's not used much, then it gets detached. It can be detached is like if it is serialized to another layer. It's basically not in active memory, but in swap file or a file inside the inside the container. If you use em clear also or things like that, it also goes to the detached state. And by, if you update the same object, in that case, you do merge. In that case, it will be fetched from the detached state and will be put to the managed state and update it, and then reflected back to the database. Once it is updated in the managed state, and if you want to do a find, when it does a find, it may not go to the database. It will just fetch it from the managed state. So if you want to get an updated value of it, you need to do em refresh and then get the value for that specific object. Similarly, if you don't use it and doesn't persist anything, or you remove or delete it, it gets garbage collected from the memory. So this is the entity instance lifecycle. The classes that have @entity, their instance lifecycle in the EJB container. Persistence unit. This is defined in your persistence.xml. I think I went through it in the beginning of the lecture. It specifies the connection parameter. So this is persistence.xml. So little correction here. It indicates the type of database to use. It specifies the connection parameters. So what it specifies is the JNDI name. Okay, the JNDI name is used by your Glassfish resource to connect. So it has a connection pool, and the JDBC resources are use the JNDI name to connect to that pool, and that pool can be connected using a few database properties, which is or 6 properties that you create. All right. So there is another hack we used to do. Instead of going to your Glassfish server and creating the pool and the JNDI JDBC resources manually, if you update your Glassfish resource.xml file in your meta info, and then refresh, clean your project, deploy it, it will create them automatically. Okay, so this is a bit of hack you can try. Okay, all right, so this is persistence.xml. The major thing about persistence XML is the persistence unit name and the classes it manages. Okay, so in this case, it is managing 2 classes here. One is contact person and property. Sorry. Persistence context. We've been talking about this file from here, the persistence context. So this is a set of managed entity instance at its given time. And it creates when one of the entity managers method is invoked. So entity manager updates or consult the persistence context when one of its method is called, and each instance must have a unique identity. It defines a scope under which a particular instances are created, persisted, and removed. Let's look at some examples. So these are some transaction scope stuff. You can have a read. The lifetime depends on the transactions. It starts when entity manager is invoked. So this is basically little things about application manage entity manager. But this is container manage entity manager. So I'll just skip through these slides. You can read through it. Yeah, it is mentioned here when using application manage entity manager, transaction management is manual, handled by the developers. A bit of mix of slides here, but yeah, we'll quickly go to okay, there is not any mention about it. All right, I'll just cover up in it 2 lines. So these are a few things about application-based entity manager, okay, which is a bit of manual task. A developer has to create a transaction context, create a transaction from the entity manager, get the entity manager from an entity manager factory, and then he has to manually close the program when things get finished. Or if he had made any DDL or DML changes, he has to manually commit it. So these are the few manual sides of application-based entity manager, which we are not doing it here. So before I go to JPQL, what are the different ways in which you can use the entity manager to do things to manage the entities? Okay, let's look at EJB and JPA property repository implementation. So you see, I get a persistence context, get an entity manager as a dependency, and using this entity manager, if I want to add a new property, simply entity manager dot persist that object that I want to persist. If I want to search, it's entity manager dot find. If I want to delete, it's simply entity manager dot remove. This code, if it would have been written using application based entity manager, this would have been like 30-40 lines extra. Okay, 3 lines here, 5 lines here. Instead of 5 lines, there would be 10 lines here, another 10 lines here, likewise. So life is a big save when container manages it. It's like you're driving a manual car that is application based entity manager, and you're driving an automatic car. The gears are managed by the gearbox. So that is container based entity manager. This is just a simple analogy. Don't take it too seriously. All righty. So where we are. So some JPQL. So JPQL is an object-oriented language for querying data, and it uses the object model of using dot to manage objects and attributes, and not tables and columns. So these are simple examples. Like if you want to fetch something from a database table called student, and you want to get select star from student, right? So JPQL is select S or P, whatever you want to do. Just use the alias and use that. If you want to fetch a specific attributes, then you can use this. You want to use conditional stuff, you can use that. You want to do grouping functions, you can use that. You want to use some dynamic queries using passing parameters, you can use this. So there are, this is positional parameter. This is an example of positional parameter, okay? And then this is an example of named parameter. So you can refer your textbook to look into different kinds of queries, okay? Named queries are like string based query. You give it a name to a string and then use it. I'll just show you some examples here. So property, so name is equal to this property and the static value. So this is a named query. If I use this, basically property dot get all query name is this value, right? So this is a named query. This gets replaced here, right? So when I call this, basically it will execute this query. Okay. So this is named query. And then you have dynamic queries. In dynamic queries, you have examples like positional parameters. You can pass named parameters. You can refer to textbook here for some examples how to use named query. So these are some examples you can look at. So you have examples like named query, how to use it, and then you have typed query, and then criteria API queries. I think we have an example of criteria API queries. Yeah, this is criteria API queries are important because they are type safe. What is meant by type safe? We'll talk about it. And then you always have that facility to run in native SQL queries. Okay, so these are all mentioned in great details in your textbook. Please have a read through them. And then you have object relation mapping. So before we start with object relation mapping, I'll give you 10 minutes break. It's 7:01. Please come back by 7:11. Okay, we'll resume at 7:11. So again, just this small info to everyone. I see a lot of people joining randomly at random times. You guys, when you join at random time, you go into a waiting room, and I have to go manually add you guys back. It creates distractions when I'm explaining something or I'm middle of something. So please try to join in between 6 to 6:05 or 6:07 so that we can have a smooth running of the lecture. Cool. Sorry. So we have object relation mapping. So mapping data in object-oriented model and object-oriented model to relation structure and vice versa. We'll look into mapping 4 different types. So one is composition, another is collection. So everything we will do by example. It will make you guys remember and recollect things faster. Okay, composition. Composition has 2 different things. One is the owning class is an entity. Okay, so owning class has this annotation at the rate entity, whereas target is actually a collection of multiple attributes in a class, and that class is not it doesn't have the annotation at the rate entity. However, it has a different annotation. It's called embeddable. So target is embedded inside the owning class, and in the owning class it is referred as embedded ID, and here it is embeddable. So if you look at this specific class called address, this address is embeddable. So embeddable means this there are like set of attributes inside this class, and this collection of attributes can be used in many other different entities, and I don't need to declare these attributes in every class. Let's say in contact person class, a contact person has attributes called address. Sorry, it's the property, right? Yeah. So the property has something called as address. You see, address is of type data type address. So instead of having 5 different other properties of address like street number, um, suburb, postcode, state code, I simply have address here. Okay. The reason is that these attributes are common with many other classes, with many other entities, and I don't need to define the attributes and getters and setters for each of them. What I do is I use them directly here as embedded, So it's the same thing. Putting it in front of the getters is accessing to properties, right? So it is embedded, and on the owning side, it is embedded, and the target, which is owned, which is address, is of type embeddable. So one thing you need to remember, when you persist property, you will have other attributes also made part of it. Okay. So once you do the project, you'll probably get more idea of it. So this is composition. When mapped to a database table, target entity doesn't have its own persistent identity. It is stored as a part of the owning identity. So at the rate embeddable on the target side, and at the rate embedded on the owning side. This is the example. So when you persist a staff, so staff has a phone number, right? So if you see the phone number, a staff can have a phone number, a person can have a phone number, a customer can have a phone number. So instead of having attributes of a phone number like country code, area code, and phone number inside each and every entities, it is wise to create a separate class that has annotation of @embeddable. Okay, and then use it in whichever entities you want to use as embedded. So embedded becomes embedded you use in the owning class. So staff has a phone number. So basically when you persist a staff object, you will actually have these 3 columns created. So you would have got that created anyway. Okay, if you would have had these attributes inside staff, you would have anyway got those columns created in the table. However, if you want to reuse that in many other entities, it's a wise way. Okay, you can see the example here. When I persist a staff object, including the ID and the name, other details are also stored in the same table under different column. It's just to make code much more reusable. Okay, this is composition. So you have 2 types. One is access by field, access by property. Something I told you, it's access is strongly recommended. Always use property. So access by field is like address dot street number. Access by property is like address dot get street number. That is the basic difference between field and property. And the second type is collection. Collection we use generally for to support data structures like list, set, and map likewise. So collection is an interface, list is an interface, set is an interface. The things that implements it is array list, has set, and has map, all these things. Okay. So if you use a collection, let's say property, property has a attribute called tag, which is a set, which is a maybe an array list. If you have a collection data structure, how do you have that in your database? Like if you want to manage it, passing it to a database, sorry, you need to use @element collection. Okay, so if you use @element collection on the getter of the tags, I'll show you. Yep. So @collection. So if you don't use collection table or any specific value to it, to the column, in that case, it will have name of the containing entity. So here, what is the name of the containing entity? It is property, right? So property, the default name of that table that will be created will be property underscore attribute name. What is the name of the attribute? Tags. So it will create property underscore tags. Okay, but we want to customize it. So the table that will be created is to have a collection table name as tag. So the table name will be tag and the column names will be values where the tags will be stored. Okay, so if you create your so from the code, when you create your database table, you will see along with property and contact person, there is another table called tag being created. And if you remove these 2 lines, you'll probably have property underscore tags. So this is something which you can use. This is something which is used when you're referring to group of objects in the collection. When you're using maps instead of set, set or array list, they are one kind. They're like a collection of an arrays or list, but a map has 2 different values. One is a key and another is a value. So one specific key refers to a specific value. So map, if you're using map, you'll again have to use @element collection, because for any collections, you need to use this annotation. And when you're using map, it will create 2 different tables. Each table, so if it would have been a map instead of set, okay, in that case, it will create name of the referencing table, which is property. It will get property, and then it will add s underscore key. Okay, name of the key. So the name of the key here would be property underscore tags. Okay, and then it will have the referencing table as property s. So this is how a map will work. And then we have a third type for called relations. Okay, so if you look at the list, first is composition, second is collection. We have covered composition, which is embeddable and embedded, and then collections, which is at the red element collection. And next is cardinality. Cardinality is when tables have relations, one to one, one to many, or many to many. So in relations, if I have one-to-one relations between two tables, where should I keep my foreign key? How the table should be designed? Okay, Cesar Janikaram has asked in between, will a table be created for embeddable class? No, we just looked at that in one of the slides. The columns, the attributes in the embeddable class will be created as columns as a part of the class or the entity class in which it is embedded. So the phone number will be an attribute in staff table. So attributes of phone number class will be the attributes of the staff table. Both should have each other as PK as a foreign key. So you can have either. You can have reference of A in B, or you can have a reference of B in A. Okay, or you can have both. It is one-to-one, so one will identify others. How about in one-to-many? So table A, so the foreign key of what on the many side? So A to B, A to B is one to many. Primary key of A should be the foreign key in B. Okay. Now what about in many to many? You need to have a bridging table, right? Bridging table with composite key of both primary keys of A and B. Good. We need to have an intermediate table with both the composite keys of both tables as primary key. So intermediate table or the bridging table, whatever. So in the relationship mapping in tables, one table, so in Java or in object relation mapping, we have these relations. We have these relations, and the focus is how about do table A know about table B? If it is yes, and B is aware of A? If it is yes, then it is a bidirectional table. That means bidirectional relationship. Both classes or both the tables or both the classes, they are aware of each other. That is bidirectional. If one class is aware of the relationship, it is unidirectional. Okay, the direction of relationship indicates whether objects on one side is aware of other. So it is denoted by a single arrow. It's unidirectional. So owner is aware of the target, but target object on one side is aware, and another side is not aware of that of the other. The direction is represented by the source class having an attribute of the target class. The direction is represented by the source class having an attribute of another class, okay, which is a target. So example, class 1 having attribute of class 2. So if it is bidirectional, you'll have no arrows. So class 1 is aware of class 2, because in class 1 you have an attribute of class 2. We'll look into an example, maybe it will be more clear. So in bidirectional mapping, class 1 has an attribute of class 2 and class 2 has an attribute of class 1. So both the classes they know about each other, and it is represented in UML by a straight line with no arrows. So cardinality is similar to RDBMS design. Object data model has cardinality. It specifies the minimum and maximum number of reference object involved in the relationship. The data structures are used to store the attributes of each other's that indicates cardinality. So you have here notations 0 to 1, 1 to 1, single object, 0 to 1, single object, null accepted, many required. So you can have a look at the list. So 1 to 1 unidirectional. In that case, class 1 has class 2 as an object. So if I show you, this is an example of unidirectional mapping. So property have contact person. So let me look at the getters of contact person. So it has a relation many to one. So there are many properties that can belong to a single contact person. Let me go back to contact person and see if the contact person is aware of it. So contact person, two properties, okay. And on the get properties, it is having map by. So having map by makes it as an owner where it is aware of the targets of the classes which is part of it. Okay, so directional is basically if you have that attribute in each other. So in that case, you have this as an bidirectional, and many one to many from property to contact person, and many to one from contact person to properties. Sorry, one to many from contact person to properties, and many to one from property to contact persons. So links to database. So if it is one-to-one relationship, relationship among records are represented by a foreign key. So if I have employee as foreign key in table department, that refers to the employee class and has managed by, then this is owner and this is target. So let's look into this. So this is junction table, a table that is usually used with many-to-many relationship. So I was talking about it a few minutes back. Yep, unidirectional relationship. So here, the branch is managed by an employee. Okay, so employee is foreign key in the branch. So there needs to be an employee first and then a branch. So what happens here, branch to employee is one-to-one relationship. One-to-one relationship. And the way it is joined is when it says managed by, it specifies the foreign key column name. And nullable is false. That means it can also accept no null values, that it has to be some value, it cannot be null. So if you say nullable is true, that means the foreign key referred here can be null. Okay, so that's nullable is false, nullable is true. And then on the manager, and inside employee is not aware of branch. You see, there is no attribute of branch inside employee. That means it is an unidirectional relationship. Only when you have branches, you can find out who are the employees managing it. But if you just have a list of employees, you won't be able to find, or unless you do a join to the branch table. So this is one-to-one unidirectional. And how do you know if it is bidirectional? If you have an attribute of branch inside employee, the relation is one-to-one, the mapping is one-to-one, and here also it is one-to-one. The joint column name is managed by, and joint column name is managed by. So here if you see, it has mapped by manager. That means it makes the manager makes it as an inverse owner. For the branch, it's a bidirectional relationship, and this is not so relationship is bidirectional here. This is managed by is the foreign key column here. You don't have a foreign key column here, but it makes it as an inverse owner because you have something called as mapped by. We'll look into one more example where it is, this is a case of bidirectional one-to-many. So in this case, one employee can manage multiple branches. So one employee can manage multiple branches. 01 is managing multiple branches. In that case, the joint column name is manager employee ID, which comes from here. Okay, and can it be null? False, so it cannot be null. So many to one with employee. Okay, and the manager here refer is when it is referred in the employee class with the branches, the field here makes it as make this class, employee class, as the inverse owner. So this is owner and this becomes inverse owner. Okay, and from the employee class to the branches, you have one-to-many relationship. All right, so if we look into this one is many to many. This branch is managed by one or more employees, and an employee may manage 0 or more branches. So this is a example of bidirectional many to many. So in that case, you provide the name of the join table. So I have a branch table, I have an employee table, and there is many to many. So I need to have a bridging table. So let's say the bridging table is branch manager. So here I have a join table, and the name of the join table is branch manager, which is mentioned here. So from the branch employee is a set, and join table name is branch manager, and the join column name is branch manager branch ID FK. So this is the primary key for the branch, which is present as a composite key in the bridging table with inverse join column as manager employee ID, referencing to the employees. Similarly, from employee side, because it is bidirectional, it will have references to the branches as an collection, and the annotation it has is many to many. Because it has mapped by, that means it is an inverse owner. Branch is the owner, and this is the inverse owner. And having mapped by two managers, and the field from the branch is managers. Okay. If we look into our example here, property has contact person. So this is from property to contact person is many to one. We have variable of property, contact person inside property, and properties inside contact person. That means it is a bidirectional, one to many to one. When I say one to many or many to one, it depends on the class that comes first. Is property to contact person is many to one, contact person to property is one to many. Both the classes are aware of each other, hence it is bidirectional mapping. Now if you look at contact person, here when I have many to one, I don't have many to one. I don't have something like cascade type persist or cascade type merge. And somebody from the chat, Subin, has asked what is cascade type. So cascade type means if I update one table, like if I update the uh, uh, like this is not a good example of it, but try to understand. If I update I cannot update the primary key here, but if I update something, it will be cascaded to other tables. I think we should have an example. Let me check. Okay, we do have an example of it. So hold on. So if you update it to your owner, the inverse owner will also be updated. So that is something meant by cascading. So you don't have to manually update the inverse owner as well. It gets updated automatically. We have those in couple of slides. So hold on. Where was I? Okay, I was talking about not one-to-one, one-to-many, many-to-one relationship. And this is many-to-one, which is we have both the references. That means it is bidirectional. And do we provide a joint column name? If you don't provide a joint column name, it will provide it by itself. And if I say contact person, so it will create a its own join column with underscore FK or something like that. When you run your program, you should be able to see and observe that change. Okay, and then from contact person to properties, it has this annotation called contact mapped by. So mapped by contact person. So this should be the name of the variable in property. Okay, so that makes contact person as inverse owner and property as the owner. Okay, so cascading, we were talking about cascading. It allows data persistence to be propagated to related entities. By default, cascade element is empty. You can have cascade persist, cascade merge, or you can do directly cascade type dot all. Okay, you don't have to do one for persist, one for merge. You can use it. Okay, you can use cascade type dot all. Okay, so you understood this is basically persistence functions to be cascade element is if it is empty. By default, cascade element is empty, which means no persistence functions are propagated to related entities. So if you look at this example, branch and employee, you see there is no cascade type mentioned here. I have an employee, I have a branch. If I persist my branch first, and then I persist my employee, the order of the statements doesn't matter because we don't have that null and the branch attribute of manager is null here, right? So initially when the branch is persisted, it will have a null value, but they are not propagated. The values are not propagated. But if you look at the next slide, when you have cascade type persist and nullable as false, that means you cannot have the foreign column as false. And if you just do, if you don't provide the employee details for the branch and just persist a branch, it will not work. But if you have an employee declared in such a way, employee object, and in the branch, if you provide the details of the branch and the employee, you don't need to persist employee separately. When you persist the branch, the employee details will also be persisted. That is called cascading. Okay. So there will be one entry into the branch table, one entry into the employee table, and the branch foreign key also updated. I hope that makes sense. So by default, cascading type is not there. So you need to specifically mention. The easy way is simply be lazy, just use this, or you can use all three, up to you. All right, entity fetching modes. So there is two types of loading. One is eager loading and another is lazy loading. Eager loading means related entities are loaded together when the owning entity is initially retrieved from the database. So do we have this example somewhere? Properties. So you see, if I get contact person, it has a list of properties, right? So there was a way in which you can specify eager loading, lazy loading, especially in mapping strategy, mapped by, and the fetching strategy you provide when you have joins. Okay, so if you have any kind of fetching strategy defined here, fetch is equals to fetch type as dot eager, so what will happen is that one contact person has a list of properties, right? It is many properties. One contact person has many properties. So when I get an access to an object of contact person, when I don't have this fetching strategy, by default, if it ends with many, it is lazy. It will not fetch the related properties into that list. Okay, so anything that ends with many is lazy. Default is lazy. That means when I have an access to an object of contact person, I don't have actually the properties in my list. When I access it, only then it is fetched. This is done in order to reduce the memory footprint. Okay, because each object carries some weight in memory. Okay, so if it is done eager, and if I do here a fetching strategy as eager, in that case, when I have an object reference of a contact person, I actually have the list of all properties object that is eager. So you don't have to do get properties to get it. You already have it. Otherwise, you need to if you have lazy, you need to call that function. If you want to get an attribute of property, you need to call that another function. That is lazy loading. Okay, this is difference between two different fetching modes: eager loading and lazy loading. The pros is eager loading is performance-wise faster, but it can sometimes lead to memory bloat or large memory footprint. The good thing is it doesn't do much of a database access because you have results already in the memory. Lazy loading is it uses less memory because the objects are not loaded in memory. They're still in the database. Only when they're referred or fetched again, they will be brought back from the database. You know, this database is in another server, and accessing the database is a considerable network delay, and this can introduce to performance issues. But for your perspective, it's not going to be any issues because your database is also on the same local host. So, but in real situation, that can be a few things you may look at. All right. Okay, mapping inheritance strategy to relational database table. So there are three different strategies. One is single table, another is joint table, and third is table per class. Let me see if we can finish this. Okay, let's see. So single table strategy is very simple. You have one single table for all. So inheritance is something which object relation is not capable, or there is a big mismatch. Okay, unlike cardinality, there is no direct equivalent of inheritance. So the strategy you need to use to implement inheritance would be single table, joint table, or table per class. So there is a subclass, there is superclass, and let's say A is the superclass, and class B extends from A and becomes the subclass. In that case, when you create objects with just one table, uh, just one table, that is single table strategy. You want to have, we'll just look into examples, it will be faster actually. So you have a user with 3 attributes, and then you have another class called retail customer that has a different attribute called balance that extends user. So retail customer will have these 3 attributes and an attribute called balance. Similarly, wholesale customer extends from user and has its own attribute called credit. So wholesale customer will ultimately have these 3 attributes and another extra attribute called credit. So single table strategy, there will be one single table with a discriminator column identifying different classes. This discriminator column contains a value unique to the object type in the given row. So it looks something like this. So these 3 columns are common. And then it introduces a discriminator column that tells if it is a retail or wholesale. If it is a retail, then it will have balance. If it is a wholesale, then it will have credit. Okay. So how do you use it, define your classes? You have @entity on 3 different classes. Public class user, it has the 3 attributes, and you define the inheritance strategy in your superclass. Okay, and you provide what would be the discriminator column name and type and length. So based on the discriminator type, the values from let's say in retail customer, which is extending user, it will have discriminator value R. That means the discriminator column, which will have the column name user type, will have the value R. That means it is a object of retail customer. Similarly, for wholesale customer, the discriminator value is W. So here you see there are 3 classes with entities. Okay, but having this meta information, this extra annotations with the discriminator column and discriminator values on the superclass and subclasses, when you execute the code, you will actually have single table. You will not have multiple tables in your database. This is single table strategy. Okay, and then you have then there are some advantages and disadvantages. You can have a look. The disadvantages, like there will be a lot of null values. You know, that means you are having space and you're not using, and then you cannot enforce any integrity constraints. Okay, because there are null values. You cannot provide it has to be an integer or something like that, because there are a large number of null values. And then there is one more strategy called joint table strategy. In joint table strategy, you'd still have a discriminator column, but if it has a value R, it will look for the column common column name and then discriminating column name in the retail customer. And similarly for wholesale, so if it is W, then it will have separate entries in the wholesale customers. So based on this strategy, you will have one table for the superclass and 2 tables for the subclasses, and there will be join based on the discriminator column and the username to get access to the other attributes. And how this is done? It is done using these annotations. Inheritance type as joined, and discriminator column as user type, providing the discriminator column value name, and join primary key join column name. Okay, so here the primary key join column name is R. So if you use this kind of strategy, join table strategy, you'll end up with 3 different tables with data based on the discriminator column. So if you persist an retail customer, you will have one entry in the superclass table and one entry in the retail customer table. Now, if you enter 2 rows into persist 2 object of wholesale customer, then you will probably have, you'll not probably, you will end up with 2 rows in the superclass table and 2 rows in the subclass table. So for my perspective, I think this is a design perspective, this is the best choice, okay, for mapping inheritance. However, from a performance perspective, it is inferior because there is a lot of joins and a lot of multiple tables being loaded from entities. There is one simplest inheritance mapping, okay? That is table per class. So a table per class is very simple, but it's like no brainer. So you have entity defined on subclass, subclasses, and superclasses, and you say inheritance type as table per class, in which you get one table for each classes. However, only the classes, only the tables related to the subclasses will have data persisted, and yeah, this here you don't have any discriminator column. So if you're looking at wholesale customers, you can directly look into this table. If you're looking at retail customer, you can look into this table. From both the relational and object point of view, this is worst because it doesn't support any polymorphic relations, and if you want to retrieve entities over persistence provider, you must use SQL join to query all tables. That means if you want to query something related to just all username, then you need to join this table and do some SQL joins. From design perspective, this is good, join table, but from simplest and easy way is use table per class. Okay. Criteria API, I would have loved to cover this, but looking conscious of time, I will cover this in the coming week lecture. Okay, this doesn't have much, few slides, and I have actually my thing open here. It is page 205. You guys can have a look. Criteria is basically to type save the queries. When you run the native queries, you can actually do a lot of database manipulations, and which is not safe. Sometimes it cannot be, it's not safe from DML operations. Sometimes it's not safe from data type. If you want to make the type safe, you can use criteria builder queries. It has a few steps. You need a builder interface to get an criteria builder, and then use the criteria builder to create to tell which table you want to, which class you want to query, and then you use the query to provide the root. That means it is like a parser containing rows returned from the table, and then parser and the root provides the hint on that parser. And based on the query selection, it's basically a selection or the projection on the value selected. If you provide few column names, only those columns will be projected over, will be selected. And then you can create conditions and everything in the predicate logic. Why this is, you can use type safe because it's basically enforces that this has to be a string type, and the data has to be from this table, and this column has to be this type. And you can use predicate logic to filter out results. That's where you can use this. And when you execute the typed query, if it is one row, if you're just calling based on one ID primary key, then it will get single result. And if you're calling multiple rows, in that case, if the result is multiple rows, then it's a result list. All right, this is an example. You can have a look. I would have loved to explain this, but looking at time and it's like 97 slides, I think I'll just give it a pass. With that much explanation, I would like you guys to look at this example as well as try to understand the explanation from the textbook. Okay, 205 page and a few other pages next to it. So container versus application manager, it's a good candidate for a long question, but you are not using application manage, but it's good to know why we are not using, because it's kind of too much of extra developer work. So these two slides contains how to obtain entity manager in application manager entity manager, that is through an entity manager's factory, passing the persistence unit name and getting the entity manager. However, when you're using container manager entity manager, it is obtained using dependency injection using the annotation at the red persistence context. I think this is something I have repeated like third time, but this is for you guys to remember and make use of it. Okay. And this is how you would have persisted or created an object and entry into a table in application based entity manager. Okay, it's like 5 different lines of code, 5-7 lines of code. However, in container managed entity manager, it's very simple. Just pass that object in persist, and if that object will be persisted to the database table. So this is creating or persisting an entity. And then you have updating an entity, which is through merge method. But however, here you need to merge, you need to commit. If anything happened, you need to roll back. But this is beautiful, isn't it? Container manages everything. You just pass the object in the function. One thing is you cannot update is the primary key. Remember that. So not. Similarly, this is to remove. In application manage, you would have done this, but in container manage, you would simply call dot remove and pass the object. All right, this is self-explanatory. This is to find. And these are some debugging information. All right, cool. Thank you, everyone. We'll close it here. I think there is one guy who just in the waiting room at the moment. I was trying to admit. One thing, guys, for the people who joined just now, like Yubo Jang or somebody who is joining late, I have a sincere request. If you're joining in middle, you're going into a waiting room and it becomes difficult for me to get distracted from the slides and coming back and admit you. So try to be on the participant list by 6, 5, 6, 10. I'm aware there is a bit of a lot of stuff here. However, I'll tell you, we have completed hell lot of things in this 4 week. It was a very quick marathon. All right, using these 4 weeks, you should be able to create end-to-end projects by now. However, we'll support you with some more extra features of security and web services in the coming week. And yeah, I'll leave you guys here. Have a good night. Enjoy. Bye.
Thank you. Bye.
Thank you, everyone.